Well, hello guys, here Mr. G with another video for the grade 12. This time we're going to answer question 1 from the diagnostic exam done or developed by Professor Rodriguez in June 2023. This is going to be, as we said, question 1, and question 1 is always a multiple choice. Me personally, I think the multiple choice are difficult questions and there is a lot of marks involved, so you be careful when you answer question 1. Take your time. And I don't know, as advice, I'll probably leave it for last in the question paper. Okay, so question 1.1 says which one of the following graph correctly represent the relationship between acceleration and mass of an object acted on by a constant net force as explained by Newton's second law. We're talking about Newton's second law, and Newton's second law have two parts. One of them, acceleration, is directly proportional to the net force, and the other one is acceleration is inversely proportional to mass. However, it is inversely proportional to mass, but it is directly proportional to the inverse of the mass. So you can see here it's directly proportional to all these terms. All right, so we are looking two options because they're speaking about mass. We are looking either when acceleration is inversely proportional to mass, or we are looking when the acceleration is directly proportional to the inverse of the mass, which is the same thing but a different graph. Okay, so in this case, if acceleration is inversely proportional to mass, it means that if acceleration increase, then mass decrease in the same proportion. Okay, which is not the case here anyway. So with the only option for that one will be B, but B, you can see that one increase and the other one decrease. And if we take acceleration directly proportional to the inverse of the mass as a unit, it means that as acceleration increase, the inverse of the mass also increase, and therefore the answer is going to be B. Answer for question 1.1 is B. So let's go to the next question. A fly hits the front window of a moving car. In comparison of the magnitude of the force exerted by the fly on the window, the magnitude of the force that is exerted by the window on the fly is, guys, this one is also Newton's law of motion. In this case, we're talking about Newton's third law. Now, Newton's third law of motion, in symbols, state that if the force from object A on B is going to be equal to the force from object B on A, let's write BA. They are going to be equal in magnitude but opposite in direction. This here with a minus there is Newton's third law. And guys, this question is related to Newton's third law. So it doesn't matter what objects are involved. If it's a fly and a car, if it is any other object, they are going to be the same. They are going to be the same, and they're speaking about the magnitudes, which is what we just speak about. So the correct answer is going to be D. This one is Newton's third law of motion. Let's go to question 1.3. An object with a mass of 30 kg is placed on an incline as shown below. The incline makes an angle of 25 degrees with the horizontal, as you can see there, guys. Which one of the following diagrams represents the resolution of the object's weight into components parallel and other perpendicular to the slope that the object is moving on? So if we just come on the object and we represent the weight, there are all the forces. We can actually represent all the forces if you will. It's not an issue, but they're asking you about the components of the weight. So I'm going to represent, for instance, normal, but this one is as a practice, guys. It's not, this is the normal. Remember, the normal is the force from the surface on the block, and they don't say the object is the object, they don't say if it's moving or not. It doesn't really matter. There is going to be frictional force pointing backwards. This object, if it's moving down, they don't say anything if it's placed the object there, so the object is moving down or is attempting to move down. So there's going to be frictional force here, which is the force also from the surface of the object, but this one is parallel. Okay, so those are the two forces, but they is not part of the question, so please don't misunderstand. We're going to weight. Now weight is part of the problem. So weight is straight down, and this weight have two components, one on the x-axis, and remember the x-axis is a parallel axis you draw to the surface. Okay, this one is the x-axis, and if you project this weight to the x, you are going to get this here to be that one there to be the component. This one is weight in x. All right, and now the y-axis is perpendicular to the x, so is this one here is the y-axis, and once more you have to determine or project that vector into the y-axis, which is this one. This one is weight in y. All right, now what else? The 25 degree of inclination is going to be this angle here. This one here is the 25 degree. Therefore, you can see that x, the weight in x, is the opposite side. So weight in x is equal to mg, or weight, multiplied by sin theta. In this case, it's 25 degree. You know, let's write the 25 degree because it is like that in the answers. And then the weight in the y-axis, you can see, is adjacent to the 25 degree, and therefore the weight in the y-axis is equal to mg cos 25 degree. All right, but now they add the vectors. So if we move this one, if we move the y-axis to here, then which version do we have? I'm going to therefore delete this one so you can see what we say there. There we go. So which one is the correct answer? So you can easily see that the correct answer is A. mg sin theta is weight in x, mg cos theta is weight in y. There we have the answer. Okay, I hope you understand. Question 1.4. A ball is thrown vertically upward. Which one of the following quantities in respect to the ball will be zero when the ball reaches the maximum height? Now, remember when the object reaches the maximum height, we're talking about projectile. The acceleration is never going to be zero. The acceleration is never going to be zero. It's always going to be there. So at the maximum height, the acceleration is going to be 9,8. Okay, now the kinetic energy, remember kinetic energy depends on velocity. Okay, so if you go to the formula for kinetic energy, is equal to half multiplied by mass multiplied by the speed square. So it depends on the speed, and the speed at the maximum height is equal to zero. The object stops there, so it can turn back. So kinetic energy is the one that is going to be zero. B is the correct answer. Potential energy is not going to be zero. If you go to potential energy, is mass, acceleration due to gravity, height. So none of this one is zero. And gravitational force is gravitational force Fg is equal to mass multiplied by acceleration due to gravity is also non-zero. So the only zero one here is going to be B. Question 1.5. A ball of mass m falls vertically and strikes the ground with a speed of 2v. Now this one is a good question here. It rebounds vertically up with a speed of v. The change in momentum of the ball is. Now what we need to know here. Change in momentum is equal to final momentum minus initial momentum. In other words, we can say that change in momentum is equal to mass multiplied by final velocity minus mass multiplied by initial velocity. And mass, if it is a common factor here, change in momentum is equal to mass, going to open bracket, final velocity minus initial velocity. These are vectors. This is how we calculate the change in momentum. Now, what do we have in this question here as the data? What do we have here? The mass is m, right? Now, Note that the object is going to move in different direction. It's going to move down, it's bouncing back there. So we have to select direction as positive, and it's either one. So for us, let's say down is positive. Alright? Down is positive. So the initial velocity is going to be positive 2v. It's given to us like that. It bounces vertically up with the speed of v. So the final velocity is v, but because it's up, it's going to be negative. Alright? And we are looking for the change in momentum. That is the question mark. Alright? So now we come and substitute. Change in momentum is equal to mass. Mass is m. Bracket. Final velocity is minus v. Minus, this minus here. Initial velocity, which is 2v. And then you solve this one. Change in momentum is equal to mass. Bracket. This one is minus 3v. And then if you sort out this one and take it out of the bracket, you get the change in momentum is equal to minus 3 mv to look like the one in the answer, but they want the magnitude, right? So in this case, the minus is not important there. So the correct answer, okay, no, they are giving you the direction there. So what does this minus means? If down is positive and this one is answer, it means that it's 3 mv upwards. That is the minus meaning the, and then here we call that is 3 mv outward. The answer is D. Guys, these questions are quite tricky and it's always there. This question is always there. So this is the way of solving this question here. Let's go to question 1.6. Now, question 1.6 said, which one of the following equations represent the principle of conservation of mechanical energy? So I want you to remember that this principle says that if the system is isolated, the total mechanical energy initial, this one is total mechanical energy initial, is equal to total mechanical energy final. Now, the system must be isolated. This one is the main principle. However, in this case, what did they use is the change in kinetic energy. So you must also know that the work done by the non-conservative forces is equal to the change in kinetic energy plus the change in potential energy. This is a very important law. This, in other words, is the law of conservation of energy and is always applicable. However, in this case, they speak about mechanical energy. So if mechanical energy, or for mechanical energy to be conserved, there must not be non-conservative force. So in other words, this must be equal to 0. And if we sort this one, we have that 0 is equal to the change in kinetic energy plus the change in potential energy. Now, if you rearrange this one, guys, if you rearrange it, and let's say, for instance, we move the potential energy to the other side, we have that the change in potential energy is equal to a minus change in potential energy is equal to the change in kinetic energy. Or it depends how you rearrange it. Or you can say, for instance, that the change in potential energy is equal to minus change in kinetic energy, which is the case of B. So B is the correct answer. I hope you understand. It's a very good question. Let's go to question 1.7. Question 1.7. When a source of sound is moving towards listener. So let's, before even go to the options, let's see what is happening when the source is moving towards the listener. Okay? Now, when the source is moving towards the listener, the wavelength of the sound is going to be compressed. Now, this is very, very tricky, guys. It seems very simple, but it's not just like that. The wavelength of sound is going to be compressed, but the wavelength of the sound emitted by the source is going to be the same. As he moving, is compressing the one that he already produces. All right? The ones that he is the one that he already produced become compressed and so on. All right? And as a result of this one, the listener is going to detect a higher frequency. So the listener is going to detect sound wave with a shorter wavelength because the source is moving toward. Okay, but the one that is going to change is the one that is detected by the listener. So let's go to the answer because it's quite tricky. They say it seems very simple and not the big problem, but it is tricky behind, or it's tricky behind this one. They say wavelength of the wave emitted by the source will become longer. You know it's not correct. The wavelength of the wave emitted by the source will become shorter. No, that is the tricky one. They say the wavelength of the wave emitted of the source will become shorter. No, the wavelength doesn't become shorter. The wavelength stays the same. The wavelength detected by the listener becomes shorter because the source is compressing the wavelength. But the wavelength of the sound emitted by the person or by the source is the same. This one is very tricky question. The wavelength of the wave perceived by the listener will be shorter than the wavelength of the wave, and this one is the correct answer. Be careful. This question is very confusing and tricky for learners. The wavelength of the wave perceived by the listener will be longer. No, that one is not correct. So the correct answers could be either B or C, but be careful, it's very tricky. But good luck with this question. Question 1.8. The graph below represents the relationship between the work done on an object and the time taken for the work of the object. So it's work done and time. The gradient of the graph represents, and guys, it's quite simple. You need to know that the gradient m is equal to change in the y-axis divided by the change in the x-axis. What do we have here? In the y-axis we have work, so it's going to be work divided by time. And this one here is the definition for power. So that one is the definition for power. Okay, so the correct answer is A. Is very simple, this one. We have two more to go. We're almost there. So question 1.9 says a force F exists between two charged particles in a vacuum. The system of charge is changed in such a way that the force between the object becomes 1/4 F. What happened during the process of transformation? And this one is a very good question. There is a question very much the same like this one we answer the videos back about also question when they have changes done there. It's a very good question here. Now they give you options. They give you options that they did change the system, and you'll have to check each of them to see which one can give you 1/4 of the force. Okay? So you need to know that in the situation here, under standard conditions, the force is going to be K Q1 Q2 divided by distance squared. Now the force change because any of these factors here change. Okay? Any of those factors change except for K, which is a constant. So this is under standard condition. They change now things here, and you need to see what happened to the new force. So for instance, let's go to try A. So for A, you have to say F is going to be equal to K, but now the charge on one of the object is half. So it's half Q1. Q2 stays the same, and then the distance stays the same. And then all you have to do is to solve this one here, and then see what is the change that will produce to their force. Now, for instance, when you solve this one, you get that is 1/2 of K Q1 Q2 divided by distance squared. So you can see that is a half of the force. All this one here is F. So it's 1/2 of F. It means that one is not the correct answer. Okay, now we have, or you have to try each of them doing the same idea I gave you here. The second one, for instance, the charge on both objects were double. So now, if the charge on each object is double, we have a space here for do it. So all you have to do is to come here and use same. F is equal to K Q1 Q2. That is R squared. This one is the normal force. But now in the new situation, they say that, or the new force, they say that K now is 2Q1 as well as 2Q2. divided by the distance squared. This is the way you always do with each of them, guys. Now if you multiply here, you get that each one is a 4k q1 q2 divided by distance squared. So this, remember, all this one is the force, so it's equal to 4 times the force, but the question said which of the changes will be 1/4, so it's also not correct. So now the distance between the object was half. So if you make the distance half, we go in here, we say F is equal to K q1 q2 divided by distance, but the distance is going to be distance squared, but the distance is going to be half, so it's half everything to the power 2. Now when you solve this one, you will get K q1 q2 divided by 1/4, this one is R, 1/4 of R squared. If you solve this one, this is simple math, guys. And now you multiply by the inverse of this one, and then you will get here that is equal to K q1 q2 divided by 1/4 of R is R squared over 4. So when we solve this one, simple math again, remember, it's just simple math. Let's do it here for all of you to see quickly. Q1 q2, okay. Now this one is divided by 1 equal, multiply, in this case, multiply by the inverse. So you move the 4 up and the R squared down. Okay, so you once more stop in 4k q1 q2 divided by the distance square. So this one is 4 times F. Also not good answer, guys. And the last one is the distance between the object was double. Now if the distance is double, we are going to say F is equal to K q1 q2. We having all the options here, so you must be following me in the video so you can see what is going on here. Now it's 2R everything squared. So if you solve this one, you have that this K q1 q2 divided by 4R squared, and then when you solve this one, is 1/4 of K q1 q2 divided by distance squared. So this one is the correct answer. Oh, it's very good because you have to solve all of them in order to get the correct answer, which is D. Now question 1.10, an astronaut of mass m has a weight W on the Earth. If the acceleration due to gravity on the moon is 1/6 of that on the Earth, the astronaut mass and weight on the moon will respectively be, and they give you different options. Now if you're watching the video, we are going to do the following. Write a comment with the correct answer for 1.10. I'm not going to answer 1.10, and then in the comment I will answer you and I'll tell you which one is the correct answer. Write the comment with the correct answer, try to do it, and then in the comments I will answer you for the correct answer of question 1.10. But thank you for watching, guys. This one is Mr. G. I hope it helped. It's a very good question. Questions 1 are always tricky, and there's a lot of mark, guys. It's 20 mark for this one. So if you pass question 1, you already get a lot of marks, okay? But thank you for watching. I hope it helped. Subscribe for the channel, thumb up. I'll see you next time. Answer question 1.10 for us here. And then I'll see you next time, Mr. G here.